Okay, so here's a version of this lottery problem from chapter 5, and this is the WebAssign version, not the textbook version. Now, I'm going to call your attention to, because somebody's asking me about this in this semester's course. Question number 3 is all worked out, and you get the worked out answers. So the only thing they've already given you is the probabilities, and I don't know if that's what's giving you a hard time. So that's why I decided to do this version of the WebAssign. But notice question number 4 is the same kind of question. I would do this one also, but I don't want to, somebody could post this for attendance. So I'm going to save that for you, or whoever wants to. Here, let's come back here. Let's come back here and then here. There we go. I'm going to click here. So what's the probability I'm going to win the grand prize? Well, let's see. There are 400 tickets, and there's only one grand prize winner, right? So the probability of the grand, here, I'm going to do some abbreviation here. Probability of grand prize is 1 out of 400. Now, we're going to assume that there's still all 400 tickets there, that one hasn't been sold, and change the probability. But so you're the first person to buy a ticket is what we'll assume. So here's second prize. Well, let's see. There are 2 second prize tickets. So that's 2 out of 400. And then there are how many third prize tickets? Let's see, there's 5 third prize tickets. So 5 out of 400. And that's the only way I can win a prize. So that means no prize is going to be, let's see, there's 8 taken up there. So that means there's 392 tickets that won't have a winning prize with it, and that's out of the 400. And then what do we win? What do we win for each of these? So the grand prize is worth $500. That's actually not too bad odds. I mean, if it's a fundraiser, what the heck, I always like 50-50s, but 50-50 raffles, but I've won a couple of times on that. But I mean, the point of those is fundraisers, not that you're going to get rich off it. But it's always fun when you win. And then third prize is what, $100? And then that's 0. Now, there's 2 ways to do this. We could subtract the $10 right now. Okay, but I figure there's a couple of ways to do this. I tend to subtract the $10 after I'm done. But I'll show you both ways. So if I multiply these, that's going to be 1.25. And that's going to be what? 1 over 200, so that's $1. And that's going to be $1.25 also. Is that right? Yeah. That's interesting. It's exactly the same. And then that's 0, of course. So if I add that up, if the tickets were free, it didn't cost me anything, I could expect in the long term, if selling all 400 tickets, they'd only pay out $3.50 per ticket. But because the tickets are costing $10, I have to subtract that 10 because I'm not going to win anything if I don't buy the ticket. So the probability that I spend that $10 is 100%. So it's kind of not, if done this way, this isn't part of the distribution. You just automatically have to do that. So what is that? The expected value or the long-term average is $6.50. So this is from your perspective as a ticket purchaser. So they're going to make in the long run $6.50 per ticket. So that'll give them a little bit of money for some money. Okay, so that's one way to do it. So here's the table. Here's the expected value. Okay. Now, what if I did it Dr. Stevens' way, the way he shows you? So what we need to change with that is this. Let me get rid of some stuff. So his method, his suggestion is take away the $10 right now. So instead of winning $500, instead of winning $500, you're only going to win $490, and instead of 200, it's 190 and 90, and then this is negative 10, of course, because you spent the money. Now, if you multiply those, that I can't do in my head. Let's see, 490 times 1 divided by 400, right? So that's a 1.225, 1.225, And then 190, well, times 2 divided by 400. We could just divide that by 200, right? That's 95 cents. Trying to line up my decimals. And that'll be 90 times, let's see, what's 90? I don't want to think this morning. Let's see, 5 times 90 divided by 400. So that's $1.12. Let's see, 1.125. And then that'll be 390 times -10 divided by 400. -975. Now, if we find the sum of all those, I guess I didn't line up my decimals for that last one. So plus 1.125, plus 0.95, plus 1.225. I should get the exact same answer I had before. Yeah, this time I got negative, unless I did it wrong. I got negative $6.45. Didn't I get negative $6.50 last time? Let me see. Did I do a mistake here? I'm subtracting $10, right? Yeah. So what's 490? So what's 490 times 1 divided by 400? So 1.2. I did that one right. And then 190 times 2 divided by 400. That's 95 cents. Yeah, that's okay. 5 times 90 divided by 400. That's $1.125. And then -10 times 392 divided by 400 is -9. Here we go, guys. I messed this up right here. And that's the extra nickel I need. You probably saw that. You were probably following along and said, what the heck is he doing? So now if we add that up, that's going to become 650. And that agrees with the other way to do it. Okay. So to me, I like doing it. I like doing it with a full winnings and then subtract the cost of the ticket. But that's your preference. You can do it however you want. It works either way. Okay, so that's how you do this call. And then I guess I should answer this. What's the interpretation of this value? Well, it's the long run average, right? So in the long run, right, I would call this choice A. It's a long run average. It's what happens. All these expected values are long run average, because the short average, when you play any one game, you could win or lose. I tell people, and this isn't right, but I tell people, hey, the mega bucks or the Powerball gets to be a really big jackpot. I'm going to go buy a ticket because, the chances of me winning, either I'm going to win or lose, right? And so in my mind, I'm thinking, okay, 50-50. Well, it's not really that, but I mean, in the short run, I could win. And you never know. It's just if it's when you buy a ticket every week, that's when you're falling into the long run averages. I'll post a bumper sticker that I have in the discussion forum. All right, so hopefully this helps you out and helps you answer that question. Let's see, it's end.